Have you ever wondered how diodes and LEDs work? Well, let's see how each of them work. Today, we will discuss about diodes and light-emitting diodes or LEDs. Let's begin with diodes. Diode is an electrical component which is used to control the direction of current flow. Current passing through a diode can only go in one direction, called forward direction. Current trying to flow the reverse direction is blocked. They're like one-way valve of electronics. This is diode's electrical symbol. This is the anode or positive side, and this is the cathode or negative side of the diode. Let's look at the example of an electrical circuit with a diode. Remember, diodes can only be connected from positive to positive and negative to negative, and you will see why later. This is an example of an electrical circuit with a diode. Let's take a closer look. This is a realistic diagram of a diode. Let's see further into the components.
This is the inside of a diode. It is made up of two semiconductors. Semiconductors are materials that have a conductivity between conductors and insulators, such as pure silicon. Here, we are going to use pure silicon for this example for both semiconductors. This is an electron. In chemistry, if an atom has 8 electrons, it is stable. This forbids any electron from going into the circuit, hindering the flow of current. However, this can be changed through a process called doping. If we add another semiconductor, this changes the impurities of the silicon and changes its conductivity, resulting to an N-type or a P-type semiconductor. N-type is excess electrons and P-type is less electrons. Doping helps allowing electrons to be left over and more free than other electrons, allowing to move as a conductor when connected to a power supply. As you can see, this is the P-type and this is the N-type.
These are the holes for electrons or positively charged as there are less electrons, and the blue with excess electrons or negatively charged. This is a p-n junction separating positive and negative parts. In the p-n junction, we get the part called the depletion region. This is where the excess from the n-type side will move over to occupy the holes in the p-type. This migration forms a barrier with a buildup of electrons and holes on opposite sides. This causes a slightly negatively charged region and a slightly positively charged region. This creates an electrical field preventing more electrons to move across. When we connect the power supply oppositely, which is positive to negative and negative to positive, the electrons will go oppositely and cause a reverse bias. While if the polarization is correct, it causes the current to flow. The p-n junction has a potential difference. On most diodes, it is 0.7 volts, thus the battery needs to be more than the diode's potential difference to allow more electrons to flow. Otherwise, the electron won't flow. Next, let's see LEDs or light-emitting diodes. LEDs are semiconductor devices that emit light when current flows through it. Electrons in the semiconductor recombine with electric holes, releasing light energy. This is a LED electrical symbol, and it is similar to diode. It is just these light arrows. Semiconductors used in LEDs are usually indium gallium nitride, aluminum gallium indium phosphide, and more. When the electrons combine with electron holes, it releases photons and light energy. And that's how diode and light-emitting diode works.